There we go. All right, I kind of made myself a little too small, I think, back in the corner there. All right, now what we're doing today, take out my nerd pen. I'm going to do problems 42 and 7, or set them up for you. This problem 42, I've had a couple questions on it, and it's tricky. It's tricky. I've already done it once. I recorded. I thought I was recording, and I wasn't. So, but that was good. We got through the trial run, and I got all the stuff loaded. All right. But anyway, I want to look at problems 42 and problem 70 for your homework in chapter 4 because they're great problems. And all right, so and the reason I am is because there's some extra little physics things that are in here, but I also want to allay any fears. These are not so much as a colleague of mine calls problems that are fastballs down the middle. These are better group type problems. I mean, how would you go about solving this problem? All right, so here it says, a woman stands on a scale. They shouldn't have said moving here. They should have just said on a scale in an elevator. Okay, that's great. Now, we did the elevator problems. When I first was getting questions on this, I was like, well, wait a minute, we did elevator problems and you all got it. But what we always had was the acceleration of the elevator. In this case, we don't have that, and that's what they're giving us all this information to find. We've got to find the acceleration of the elevator. All right, so here we go. It says a woman stands on a scale in a moving elevator. Her mass is 58 kilograms, and the combined mass of the elevator and the scale is an additional 729 kilograms. So let's write down what we know so far. All right, so the mass of the woman, 58 kilograms. Mass of the elevator, 729 kilograms. So we'll put all this in later. And and then I think they told us that there's a tension force. All right. Starting from rest, the elevator accelerates upward. All right. So it's got an upward acceleration, which we don't know. All right. So I wrote in upward acceleration that we don't know right here. All right. Now let's go back and see what else they got. During the hoisting cable applies a force of 9,820 newtons. I'm going to assume that's upward. Okay. What does the scale read in newtons during the acceleration? All right, so we've got to find the acceleration. Then we're back to the problem, like the elevator problems we did in class. All right, so let's take a look here. 9,820 newtons. All right, so let's draw the picture. Here's the woman in the elevator. All right. Woman in the elevator, standing on a scale. All right. Now we're not worried about the normal force on the scale right now because we've got a tension force pulling this thing up at 9,820 newtons. All right. So, and it's accelerating upward, and we've got another force that's going down here, and that's the mass of the woman. That's the combined mass of the woman and the elevator times g. All right, so some of the force. So now let's find A. Let's find the acceleration. Then we're golden. Once we find the acceleration, we're done. All right, so we'll go, okay, well, the sum of the forces in the y direction is equal to mw plus me times A, and it's positive, which is equal to this tension force, which is going up, T, minus the combined mass of the woman and the elevator times G. Solve for A. Solve for A. Then you're golden. Solve for that acceleration that's going up. All right? You have this number, 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 and you have that number. You've got one equation, one unknown. We're golden. But now, part 2, go to the woman on the scale. So in part 2, we go to the woman on the scale, and so here she is standing on the scale. Here's the scale. Here she is standing on the scale. Okay, so she's standing on the scale. So she's got her mg going down and the normal force going up. But also there's an acceleration in this thing going upward. So her mass is accelerating upward at this rate right here. So we take the sum of the forces in the y direction is equal to woman on the scale. Calculate her normal force. All right. So we go, all right, well, sum of the MW times A, which you got from up here, is equal to the normal force minus MWG. So that's the normal force that you're after. You had to find that acceleration first. All right? So we're done with that problem, and this will send this along.